Alright, these are our notes for section 7.3 on factoring polynomials. And we're going to factor again today. This is probably the fourth, fifth time we've seen that. And the only difference is we're going to be factoring with polynomials. Now we have factored quadratics, which is when the greatest exponent is a 2. Today, though, the exponent is going to be something else. It be something larger. Before we get there, though, we're going to review two things. First thing is factoring itself. So we got a problem here. 3x squared minus 23x plus 14 equals 0. We've got three terms, so we're going to x factor this. A times c goes on top, so it would be 3 times 14, which is 42. Negative 23 goes on the bottom, and we want two numbers on the sides that are going to multiply to 42 but add to negative 23. And those two numbers happen to be negative 21 and negative 2. Now we cannot use our shortcut here, because a is something other than 1. A is 3 in this case. So we got to expand then group. 3x squared minus 21x minus 2x plus 14 equals 0. We take the first two and then the second two. And greatest common factor, take the greatest common factor out of both. 3x squared minus 21x. Greatest common factor here is 3x. And we are left with x minus 7. Minus 2x plus 14, greatest common factor is negative 2, and we're left with x minus 7 equals 0. Now we're going to rewrite this. 3x minus 2, the GCFs from both sets becomes one set of parentheses, and x minus 7 becomes the other. Those equal 0. Set each part equal to 0. This is called the zero product property. Add 2. 3x equals 2, divide by 3. So one of our answers is 2/3. The other one's much easier to find. Add 7, x equals 7. There are two answers here. Now notice our greatest exponent was a 2, and we have two answers. That's going to be important. We'll talk about that here in a couple minutes. The other thing we need to review is power to a power, what that actually means. If we've got x cubed squared, where x cubed is in parentheses and then a square on the outside, remember if it's a power to a power, we multiply those together, and 3 times 2 is 6. So our answer here would be x to the 6th. Now we could go the other direction with that. If we had x to the 6th, we could pull that apart and make it x cubed squared. It works both directions. And what we're going to need to know is that pulling apart aspect of it. So we've got two examples here. We have x to the 10th and x to the 12th. We could take x to the 10th and we could make it x to the 5th squared. And that works because 5 times 2 is 10. We could also make it x squared to the 5th. That's also acceptable because 2 times 5 is the same as 5 times 2. Now we want this one. We want the first one there where the outside exponent is a 2. Okay, keep that in mind as we're rewriting these today. We want that outer exponent on the outside of the parentheses to be a 2. Second one here, x to the 12th. We can make that x to the 6th squared, because again we want that outer exponent to be a 2. Both of those ideas are going to be important as we work through these examples. The first thing we're going to look at is rewriting polynomials as quadratics, because we can factor a quadratic. That's what we just reviewed, that first example. To check and see if we can rewrite something as a quadratic, we want to look at the biggest exponent, and we want to see if we can rewrite it. And we want to rewrite it so that that second term, in this case it's x cubed, can be inside of our parentheses. So if our problem is 2x to the 6th plus x cubed plus 9, we're going to look at x to the 6th and we're going to see if we can rewrite it. We can rewrite it as x cubed squared, and again remember I told you want that square on the outside of the parentheses. So we can rewrite it. We can write it as x cubed squared. Now notice that the x cubed in our parentheses matches the x cubed in our problem, and that's what we want. If they match, it's yes, you can rewrite it. That was a test to see if we could rewrite it. And then if we go ahead and rewrite the problem, it would be 2 times x cubed squared plus x cubed plus 9. And that would be our answer if we rewrite it. What's important is that what's in the parentheses, that exponent on the variable, has to match the one in the second term. They have to be the same. If they don't match, if it fails that test, then the answer is no, you can't rewrite it. So we got another example here. X to the fourth plus 2x cubed plus 1. I'm going to check that first term, x to the fourth. You can rewrite it as x squared squared, but that squared doesn't match the cube in the middle. They don't match, so the answer is no. They don't rewrite, and it stays the way it was. Okay? It's not possible to rewrite this one. If it's not possible to rewrite like that, then it's going to be not possible to factor. Now we're going to take those ideas, all three of those ideas we just talked about, and we're going to put them into 4 examples. Now everything's the same as when we factored before. The difference is that exponent's going to change. We have an extra step at the end, and you'll see what it is here in a second. Before we get there, one thing to remember is that the degree, and we've talked about the degree before, remember that's the biggest exponent, is the max answers you should have. Max number of answers you should have. And they may be real, they may be irrational, they may be complex, they may be rational, it depends, but you can have at most that many answers. So our first example here is x to the fourth minus 29x squared plus 100. Let's check real quick and see if we can rewrite it. So we're going to check that first term, x to the fourth. We can make it x squared squared. Squared here matches the squared in the middle. So this is a yes, we can rewrite. And when we can rewrite it, then we can factor it. We're going to make it x squared squared minus 29x squared plus 100 equals 0. Now everything else stays the same, just like it would in that first example we did, the review problem. We're going to go ahead and x factor it. A times c goes on top, which in this case is 1 times 100. B goes on the bottom, which is negative 29. And we want two numbers that multiply to 100 but add to negative 29. Those two numbers happen to be negative 4 and negative 25. And we can also use our shortcut here because A is 1. So this is where the different step is. Instead of being x minus 4 in parentheses and x minus 25, that middle term there is an x squared. So it becomes x squared minus 4 and x squared minus 25 equals 0. So this is a no. It's not just x's, it's x squared in this case. Now we do everything the same, take them apart, set them separately equal to 0. So x squared minus 4 equals 0 and x squared minus 25 equals 0. Add 4 to both sides. To get rid of a square, you square root, and don't forget your plus minus. So the first two answers are plus and minus 2 because the square root of 4 is 2. On the other side, we add 25 to both sides. Square root. Don't forget our plus minus. So x equals plus or minus 5, and we have 4 answers here. We have negative 5, positive 5, negative 2, positive 2. Notice we had 4 answers, and the degree on our problem was 4. The biggest exponent was 4. That's important, that they match the number. Okay? And that's what we're going to be doing today. The catch is that extra step at the end. Instead of being x minus 4, x minus 25, it's x squared minus 24 and x squared minus 25. Let's look at another example. Okay, this one is x cubed plus x squared plus 21x equals 0. Now, on that other example, the exponent was even. On this one, the greatest exponent is odd. And usually when it's odd, not always, but sometimes when it's odd, there's going to be a greatest common factor. And that's what we should check for first. Well, if we look, there's an x in all of them. So we could factor out an x. We have x times x squared plus 10x plus 21 in parentheses equals 0. And now we have a quadratic in our parentheses. When we pull that apart, we have to take this first number out in front, first variable, and set it equal to 0. And it is one of the answers, so don't forget about it. And then we have x squared plus 10x plus 21 equals 0. It's a trinomial, so we can x factor it. 21 on top, 10 on the bottom. What two numbers will multiply to 21 but add to 10? Happen to be 7 and 3. Use your shortcut because a is 1, so x plus 7, x plus 3 equals 0. Pull them apart using the zero product property. So x equals negative 7, x equals negative 3. We have two more answers. So we ended up getting 3. We have negative 7, negative 3, and 0. Notice again we have 3 answers. And the exponent on our problem, the degree, was 3. They match. We should have that same number. Now the only time that won't happen is when we have rational exponents or radical equations. We can still factor them the same way, but we can't tell by the degree what the number of answers will be. So we got two examples, one of each type. The first one's going to be rational exponents. Remember, rational exponents mean that the exponents are fractions. And we do everything the same. Okay, we're going to test it first. We're going to test that first term. We have x to the 1/2. And you can rewrite x to the 1/2 as x to the 1/4 squared, because 1/4 times 2 is really 1/2. It would be 2 over 4 reduces to 1/2. And that's what we want to see. That works. Since that 1/4, x to the 1/4 is the same as what's in the middle, we can go ahead and factor them. It is rewritable. So we're going to make it x to the 1/4 squared minus x to the 1/4 minus 6 equals 0. Make an x. A times c on top, which in this case is negative 6. B on the bottom, negative 1. Two numbers that multiply to negative 6 but add to negative 1. They happen to be negative 3 and 2. Everything's still the same. The only difference is what our b here is, because what's in our parentheses. X to the 1/4 minus 3, x to the 1/4 plus 2 equals 0. We separate them out. X to the 1/4 minus 3 equals 0. X to the 1/4 plus 2 equals 0. Add 3. X to the 1/4 equals 3. Here's the catch now. We have to get rid of that rational exponent. So we're going to raise both sides to a power, and we want a power that's going to get rid of a 1/4. To do that, we're going to use the denominator. Okay, our denominator in this case is 4, so we're going to raise both sides to the 4th power. 1/4 times 4, that would cancel, so we get x equals 3 to the 4th, and 3 to the 4th is 81. Okay, and that's part of the answer to our problem. We have to do the same thing with the other side. X to the 1/4 equals negative 2. Raise both sides to the 4th power. 1/4 times 4 is going to cancel and make 1, so x equals negative 2 to the 4th. Negative 2 times negative 2 times negative 2 times negative 2 is positive 16. And there's the other answer. Now, whenever we have rational or radical exponents, you need to check your answer. Okay? In this case, we have two things we need to check. We need to check 81 and we need to check 16. We're going to plug them both back into the original problem. So it would be 81 to the 1/4, not 1/4, 1/2, minus 81 to the 1/4, minus 6 equals 0. 81 to the 1/2, we could put that in our calculator. It's really the square root of 81, which is 9. Minus 81 to the 1/4, you could put that in your calculator again, or you could think of it as the 4th root of 81, which happens to be 3, and then minus 6 equals 0. 9 minus 3 minus 6, that's 0 equals 0. Well, that one works. So this is part of the answer to our problem. Now let's check 16. If we have 16 to the 1/2 minus 16 to the 1/4 minus 6 equals 0. 16 to the 1/2, that's the square root of 16, which is 4. Minus 16 to the 1/4, that's really the 4th root of 16, which is 2. If you don't remember what these are, remember we have that chart we can use, or we could just put it in our calculator. Put it in parentheses, put your exponent in parentheses, and do division. 1 divided by 4. Minus 6 equals 0. So we have 4 minus 2 minus 6 equals 0. Well, 4 minus 2 is 2. 2 minus 6 is negative 4. Negative 4 equals 0. That doesn't work. So 16 is not one of the answers to our problem. And the only answer we have is the one that worked, is 81. All right, we have one more example. It's a radical equation, but we're going to solve it. We're going to rewrite it as rational exponents, and we'll solve it the same way. Now, we've got x minus 6 square roots of x equals 7. First thing we need to do is get it equal to 0, so we will subtract 7. X minus 6 square root x minus 7 equals 0. Now we're going to take that square root and we're going to rewrite it as a rational exponent. X minus 6 times x to the 1/2. Remember, the square root of x is really x to the 1/2. The index becomes the denominator and the exponent on our variable becomes the numerator. Minus 7 equals 0. You can check that in your head. X is our first term. We could rewrite x to the first as x to the 1/2 squared. 1/2, 1/2, it does work out. So we can factor this. X minus 6x to the 1/2 minus 7 equals 0. We're going to x factor. Minus 7 on top, minus 6 on the bottom. Two numbers that multiply to negative 7 but add to negative 6. Negative 7 and positive 1. Now remember, when you use your shortcut, because a is 1, we make it x to the 1/2 minus 7, x to the 1/2 plus 1 equals 0. Pull them apart. X to the 1/2 minus 7 equals 0. X to the 1/2 plus 1 equals 0. Add 7 to both sides. X to the 1/2 equals 7. We have to square that to get rid of our exponent. 1/2 times 2 is going to be 1, so we get x equals 7 squared, which is 49. Do the same thing on the other one. Subtract 1. X to the 1/2 equals negative 1. Square both sides. So x equals negative 1 squared is positive 1. We had rational exponents when we rewrote it, so we need to check the answers. Let's plug them back into the original. We'll start with 49. 49 minus 6 times the square root of 49 equals 7. 49 minus 6 times the square root of 49 is 7 equals 7. 49 minus 6 times 7 is 42 equals 7. 49 minus 42 is 7, so 7 equals 7. That one works. This one is part of the answer to our problem. Let's check 1. 1 minus 6 times the square root of 1 equals 7. Be 1 minus square root of 1 is 1, so it would be 6 times 1 equals 7. 1 minus 6 times 1 is really 1 minus 6 equals 7. 1 minus 6 is minus 5. Minus 5 does not equal 7. So this answer is a no. 1 does not work in our problem. So the only answer we have is 49. And that would be the only answer to our problem, because it's the only one that worked out when we checked it. Now those are your notes on section 7.3 on factoring polynomials. Remember, it is the same as what we've done before. We are just factoring. The difference is What goes in our parentheses isn't going to be an x. It may be an x to the 1/2, maybe an x to the 1/4, maybe an x squared, and we have to take that into consideration as we solve it. If you have any questions, bring them to class next time. And again, those are your notes on section 7.3 on factoring polynomials.